All right. So again, we're doing AP Unit 215, which is called semi-log plots. So a semi-log plot is like a weird but different way to graph information on a coordinate grid. A semi-log plot graph looks like the one on the right-hand side. So on the left-hand side, you've got your normal x, y coordinate. On the right-hand side, this is what's called a semi-log plot. They are used to graph things that are mostly exponential. So if you think about if I had to graph something that's exponential in which my data grows so fast that it's hard to put it on a graph. So like if I use, for example, what's here, if my x's are linear, 1, 2, 3, 4, 5, or 1, 3, 4, 6, 8, okay? My y's are increasing, right, and at a fast rate. If I try to put this on a normal XY chart, either they're going to go off my chart, right? Like it's going to go way off the chart. Or I'll have to increase this by like 200s. Like I'd have to mark this by like 200, 400, 600, 800, like that, right? You'd have to adjust your scale so much that if I'm at this, let's say this is 0, 1, 2, 3, 4, 5. Actually, let me go by 2s so I can fit it. 2, 4, 6, 8, 10, 12. If I wanted to plot these, 110 is going to be so low. 340 also still so low. Now I'm getting 498, like halfway to that first marker. 6205 would be here, and 8905 would be all the way up here. Okay, so I'd see this exponential growth here in my graph. Okay. But what you're not seeing as much is the separation between the output of when my input is 1, when my input's 3, when my input's 4. They look so close together. So instead of plotting something like that on a regular traditional XY coordinate grid, we plot it on something called a semi-log plot. On a semi-log plot, the x-axis is your typical axis where it would go. This would be 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth, okay? Now pay attention to the y-axis. What's happening on the y-axis is that I'm going by powers of 10 instead of just your normal scale. So my first break is 10 to the first, which would be 10. My second break is 10 to the second, which would be 100. Up here would be 10 to the third, which would be 1,000. And then within those breaks, you're also breaking them down differently. From 1 to 10, the biggest jump is from 1 to 2. 2 to 3 is smaller, 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 all the way till it gets to 10. And then from 10 to 100, now we're going by 10. So it'd be 10. The next line would be 20. The next line would be 30, then 40, then 50, then 60, then 70, then 80, then 90. And then from 100 to 1,000, if I divide that by 10s, you're going by hundreds. So this would be 200, this would be 300, this would be 400, 500, 600, 700, 800. I don't know why I picked the same color. 900. So again, a semi-log plot will have constant growth on the bottom, like 0, 1, 2, 3, 4, 5, whatever. And then on your x-axis. And then on your vertical axis, you're going by powers of 10. So if I wanted to plot these same points, then my 110 would be here. 346, I'd go to 3, and I'd go in between 40 and 50 would be here. 498, I'd go to 4, and I'd go almost to that line at 100. 6205, 6205, and 8905, 8905. Now, what kind of shape would you say these dots take on this graph? A linear shape. So if I take, and this one of the most important takeaways of this lesson, is if I take exponential data and I plot it on a semi-log plot, it appears linear. So some multiple choice questions will give you options of different graphs, and it will say if my initial data is exponential, which of the following would be an appropriate way to model it, or which would it look like? And if you're looking at a semi-log plot, then the semi-log plot of your exponential data will appear linear. It doesn't have to be perfect, but it will appear linear. Not from scratch, like they'll give you, like there's going to be times in which you have to plot it like this. On your AP exam, you'll never plot anything.
So we don't need to.
It would be but not where to draw the lines. No. You have to understand what it looks like. You have to be able to spot it from multiple choice, basically, is what it is. So, for example, one, it says plot the data on the coordinate grid on the semi-log graph, and then is the data exponential? If yes, find the regression equation for the data, okay? So if I were to plot it on the coordinate grid first, then it's going to go to, well, let me go by, I'm going to go 0, 2, 4, 6, 8, 10, so we can fit it all. And then I need to get from 0 to 830. So I'm going to do the same thing I did before, 200, 400, 600, 800. So 2, 8.2 is going to be really low. 4, 17.5, not much higher. 6, 90, 7.2, 7, 398, and 8, 832. Oops, I just skipped over. This would be 7. 8. It's okay, I feel you. 832. Okay. So on my coordinate grid, my typical coordinate grid, my shape is exponential, which is what it should be. Now on the semi-log plot, I'm going to do the same thing. I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8 is the biggest I need to get to. And then 2, 8.2 is going to be about there. 4, 17.5. Each of these lines would be 10. So it's halfway, or not halfway, but a little bit closer to 20. 6, 97.2. So like right under the 100 marker. 7, 398. So on this would be 200, 300, 400, put it closer, 500, 600, 700, 800, 900, just so we can get an idea. So 7, 398, and 8, 832. And it's not perfectly linear, but it's definitely more linear than my initial graph. So is the data exponential? Yes. And if so, find the regression equation for the data. So it doesn't ask you, this time, if it is exponential, it doesn't tell you explicitly which regression, but if it's exponential, we're running the regression model, okay? So we're going to enter all this stuff into our calculator, which is good practice because you're going to have to do this a couple times on your test. I'm going to go to my L1, 2, 4, 6, 7, 8. And I'm going to my L2, 8.2, 17.5, 97.2, 398.4, and 832.8. And then I'm going to run my regression exponential. And I get y equals or f of x equals, because it doesn't say it's a function this time, so it doesn't really matter which one you use. A is 1.1165, so 1.117 times B, 2.234 to the x. Just like every other test you've taken and all the other practices on your test this time, on your 210 to 214 test, it will ask you to go further with this. It might say, and that's how I kind of twisted it multiple choice. It might say find the regression, but then you have to use the regression to answer a question. So find the regression and then find where the value, where your input is blank or where your output is blank. So just be prepared to definitely do that kind of stuff. B says complete the table to find log of y, then find a linear regression of this. So if we take exponential data and we log it, it becomes linear. So I'm going to take this chart on the bottom. It's the same values, but I'm going to find the logs of each of those. Now here's your option. And I give you this option on your test as well. You can either, all right, so your option is to either use the chart and fill in each of those individual logs. So if I just go back to my initial screen, I would log 8.2, log 17.5, log 97.2. This is one option, okay? And then you can fill in the chart. So on your test, I did the same thing. I gave you a chart and it says, if you want to fill in the chart, but it's optional. It's not worth points, okay? Because your other option is if I just go to my data set, so this is what I would want to know how to do because I think this is easier, okay? I would go to my data set. I already have 1 and 2 in there. And then in the L3 list, I would literally write log 8.2 and it will convert it for me. Log 8.2, log 17.5, log 97.2, log 398.4, log 832.8. So it's filling it into L3 for me. You could replace L2 with it. It doesn't matter. I just think it's easier because we already had L2 in there. It's easier just to use it next to it. And again, same things that happen on your test. You can fill in the chart, but you don't have to. It's not worth points. So this would be 0. And if you're going to do it, you got to keep the 3 decimal places every time. 1, 3, 4, 0, 1.243, 1.988, 2.600, and 2.921. Now your regression will be a little bit off if you've rounded it. So when you look at your multiple choice, it may not be perfect. Just keep that in mind. It should be close. Like it's not going to be 2 answers that are the same. But it will not be perfect. All right, so now I want to run a linear regression using X as my input and log of Y as my output. So when I go to stat and I go to calc, I'm going to go to the linear regression, my AX plus B, and I'm going to use L1 as my input, but what's my output? L3. To get to L3, I go to second stat, and that's where the list names are. And I go to L3. And then I'm going to run it. And I get my Y equals A is 0.349, X plus B 0.048. I kept the one that was in list 3. If you round it, your answer's not going to be exactly that. It will be close. But it will not be exactly that. Yeah. How do you change it into L3? So when you go to your stat, you go to edit. No, go to calc. Here, you go to second stat, and that's where the list names are. All right, you should have gotten Y equals 3.083 times 1.94 to the X as your exponential regression. Good on that one? Yes? Yes. Okay. We're going to skip the second part. I'm going to come back to it in a second. Then complete the table. Notice, like, if you run it, like if you do it in your chart, on that view, it will keep 4 decimal places, which is a little bit more accurate. If you are going to fill out the chart and then use the chart and round it, obviously it's not going to match perfectly. So keep that in mind. When I do the key, like when I create these questions, I'm using the chart in your calculator, not the rounded chart. So if this is a multiple choice question and you get to your Y equals and it's a little bit off, like a Y equals 0.173, maybe X plus something, don't panic if you've rounded. It will be a little bit off, okay? But just keep in mind that the process I will use to get those answers is keeping it in the calculator. How'd we do on the linear model? Good? Yeah. Okay. So what I'm about to like show you, you don't need to do on your test, but it's about understanding things. And that is, if we log both sides of the equation, we basically are taking our exponential model, logging it, putting it on a semi-log graph, which makes it linear, okay? So when it says take the log of both sides of the equation, really we're going to log the right-hand side of the equation. So I would get Y equals, I'm going to log, and I could log any base. It could be log of the base that's got the exponent. It could be log of 10. It doesn't matter. Log of 0.83 or 3.083 times 1.94 to the x, okay? So I'm logging the other side of the equation, which is going to take my exponential function and it's going to make it linear. Now, what would you do on that log on the right-hand side if I wanted to expand this? What does it become? It's a product, right? What does it become? Addition. So this would become log of 3.083 plus log of 1.494 to the x. And then what happens on the exponent when we expand? It goes to the front. So this becomes log of 3.083 plus x times log of 1.494. Again, you don't need to do this because your calculator will find the regression using the linear model. But understanding what we just did is what's important. If I actually type log of 3.083 into the calculator, I'm going to get a number, right? This is a constant. This is your b in terms of your y equals mx plus b, plus x times this is also a constant, and that's your m. So by logging it, which is what you're doing when you're putting it on a semi-log plot, you are making it linear, okay? That's the conversion. It takes something that is in log form, you would expand it, you would follow the rules of expansion, your x would bump to the front, which makes it a product, and then that becomes your linear model. You do not need to do this on your test. Your test, you can use your graphing utility to do it, okay? But if you see instructions that say, technically it says log both sides of the model, but we don't need to log the y because we are changing the data and how it looks, not changing both sides of the equation. Oh. All right, so then this is how else you could see semi-log plots. Example 3 says, determine which graph represents the exponential function and explain why. So there's really two ways that you can see graph of data to say that it's exponential. One is its original function, like a regular coordinate grid in which you see the exponential model. The other is what? What am I looking for if it's a semi-log plot? We're looking for a linear shape. So on the first one, look at the y, right? The y's, this is how I'll know one if it's semi-log plot or if it's traditional. These are by powers of 10, okay? And my shape over, and look at the bottom part too, because they'll trick you with that. Look at the bottom part, make sure it is your original, your standard inputs. This would be the shape of data that was exponential that I took and put on a semi-log plot. If you look at the second one, this is a traditional input and output graph, and my line is linear, so that is not exponential. And if I go to the last one, my input is linear, my output is by powers of 10, which is semi-log, but this takes on exponential shape, okay? So the only one that would be correct is that first one, okay? Because the data, or exponential data, on a semi-log plot looks linear or takes on a linear shape, something like that. Questions on that one? All right, and then example 4, the table gives values for a function f at selected values of m. Which of the following could represent these data in a semi-log plot where the vertical axis is log scaled? So notice your initial data. This is not already logged. This is your initial data. What does that data look like? It looks exponential, right? It has high growth on your output, right? It looks like it's exponential, which means if I look at these, if I go to A, both my output and my input are your traditional. They're scaled differently, but they are traditional, so it's not that one. I go to the left, B, still traditional. C is the first one where my input is traditional, but my output is powers of 10. And D is also traditional on the input and output powers of 10. So which of these would represent the exponential model? C. Looking for a log plot with a linear shape. Questions on that one? All right, now let's do some AP review examples. So if you look at example 1, it says two function models, K and M, are constructed to represent the sales of a product at a group of grocery stores. Both K of T and M of T represent the sales of the product in thousands of units. After T weeks, for T being greater than or equal to 2, if K of T is 14 minus 2.885 LNT, and M of T is negative T plus 14, what's the first time that T sales predicted by the log model will be 0.1 thousandth unit more than the predicted sales by the linear model? Where do you even begin? We're trying to say what's the first time that sales predicted by the log model will be 0.1 thousand more than sales predicted by a linear model. So how could we find out what the difference between the two models are? How would if I wanted to know the difference between the log and the linear, what would you normally do? Let's say you didn't even have an equation, and I wanted to find the difference between the log model and the linear model. What would you do to those numbers? Subtract them, yes? Can we do the same thing with equations? Yes, we can. So if I wanted to know the difference between the log equation and the linear equation, I can literally say, take my log equation, subtract from it my linear equation, and I want that to be 0.1. Does that make sense? So if I want the difference, I don't just want it to be 0.1, I want the difference between them both to be 0.1. So in my y1, I'm putting both. In my y1, I'm doing the log 14 or minus 2.885 ln of x minus the linear negative t plus 14. This is going to model not my initial model, but it's going to tell me the difference between these models. So when I type it in, I'm going to go y1. And I'm going to do 14 minus 2.885 ln of x minus, I'll close my parentheses again, minus negative t plus 14. Well, I kept the parentheses, I put the negative in front of the parentheses. If you distribute it, you distribute it. And I need this difference to be what? I need it to be 0.1. So I'm going to put in my second one, 0.1. And I'm going to graph it. Oh, my window's so strange. Hang on. All right, so here I've got the difference is the blue. And the 0.1 is the red. Well, I want to know where the difference equals 0.1, right? But read into your question a little bit further because there's something there that can be easily missed. And it is that I want to know where it is after the t weeks where t is greater than or equal to 2. So if I look for where these cross, one's going to cross here. And one's going to cross, wow, if I could hold this steady, it'd be good. One's going to cross here. Why is the second one going to be your answer? Because the first one happens before 2. So I'm going to look for where it crosses the second time. You could also have restricted your window. I could have also said window, and I could make my y min 2. My x min, sorry. And it will actually eliminate that first time it crosses. And now I'm looking for the intersection. Second, trace, intersect. I'm on the first curve, second curve. And guess where they meet? And it's that 4.324. I purposely picked this question to review because this is not an easy question, okay? But it is something that they could ask you to do. So it's important that you understand. And I'm not saying that's the only way to do this. That's how my brain thought to do it. Doesn't mean it's the only way to do it. But one of the most important things is to be paying attention to any kind of restrictions, like that t has to be greater than or equal to 2. Sure. Consider functions f and g given by f of x equals log base 10 of x minus 1 plus log base 10 of x plus 3. And g of x equals log base 10 of x plus 9. In the xy plane, what are all the x coordinates of the points of intersection of the graphs of f and g? I'll tell you, this would be a non-calculator question. What would you do here? How do you know when two things intersect? You could. So if you were looking to see like if they're like a parallel, you would do opposite reciprocal. But if I'm trying to figure out where two things intersect, 2 points of intersection, and I don't have a graphing utility, set them equal to each other. Let's start there. So my f of x, which is log base 10 of x minus 1 plus log base 10 of x plus 3. I want to know where this equals log base 10 of x plus 9. And I don't even need like the log base 10s. Where would you go from there? Condense it. So the left-hand side has 2 logs. So I'm going to make this log x minus 1 times x plus 3, because when we condense and it's addition, we multiply. This would both be log base 10. Then what? Good, because there's a log on either side of the equal sign. We're going to cancel these logs out. And I'd get x minus 1 times x plus 3 equals x plus 9. Then what? Foil out the left-hand side. X squared plus 2x minus 3 equals x plus 9. Then what? Good. Got to get everything to one side. X squared plus x minus 12 equals 0. Then what? Factor it. Factors a negative 12 that sum to positive 1. Positive 4. Negative 3. Split and solve. X equals negative 4 and x equals positive 3. Then what? Do I get excited because that's an answer there and I circle it and I move on? And you get it wrong. Why? You have to check your log answers. So I will go back up to the beginning and I will say all of these things, when I plug my values back in, have to remain bigger than 0, right? So if I plug in the negative 4, here, this becomes negative. Here, this becomes negative. It doesn't even matter. If it happens once, I rule that answer out. So that means negative 4 is not actually an option. And then I would check 3. 3 minus 1 is 2. That's good. 3 plus 3 is 6. That's good. 3 plus 9 is 12. That's good. So 3 is the only answer. And a lot of times you'll see something like that. Like if you notice, A says only. B doesn't say anything about only. But usually if it's something you need to check, and it doesn't mean you're always going to rule it out, but if it's something that you need to check, you'll get almost a hint like that. Like if you see something that says only and you have 2 answers, think like, is it possible that one of them doesn't work and why isn't it? So this is a good tip because your test on Tuesday, you're going to have log equations and there's going to be questions that you have to check, okay? And remember, when we get to graphs of logs, our domain is always impacted, or inequalities of logs, our domain is always impacted because of those. All right, let's go to example 3. See if this is a little bit better. We'll maybe step our way back to 1, but I am going to make you do 1. Says, in a certain simulation, the population of bacteria colony can be modeled using a geometric sequence where the first day of the simulation is day 1. The population on day 4 is 4,000 bacteria, and the population on day 8 is 49,000 bacteria. What was the population of the colony on day 6 based on the simulation? This would be a calculator-based question. I'll tell you that much. What do? You could put in your stat plot. What are the coordinate points you're going to put in that stat plot? 4,000, and 8, 49,000. And then what kind of model are you going to run? What kind of regression? Exponential, because geometric, exponential. Not exactly the same thing. These would be dots instead of a line, but other than that, bless you, they behave the same way. So I'm going to go to stat, I'm going to go to calc, I'm going to go to exponential. Make sure your list is L1 and L2. Oops, I just said the wrong thing. And this time I'm going to store it. I get y equals 326.531 times 1.871 to the x. That would be my exponential model. And then it says, what was the population of the colony on day 6? So is the day the input or the output? The input, all I have to do is do y1 of 6. And I get 14,000. If it said, on what day does the bacteria hit blank, now that is your what? Input or output? Output, okay? So you would do what if it gave you the output? Y1, Y2, and see where they cross. Good. Questions? So you will see this type of question for sure built into an FRQ where it gives you the different parts. You have to set up your equations. What equations could be used to solve it? What are your A and your B? And then use it to do something. But you could also see it in a multiple choice question like this.